Hello everyone, let's take a look at this problem from LeetCode. The problem name is Pythagorean Distance Nodes in a tree. Let me give a brief of what the problem is and then we'll jump on to the solution approach. So the problem here gives us an undirected tree. That undirected tree is given to us in the form of edges that are there in the tree. Also we are given 3 target nodes and we have to find all the nodes in the tree whose distance from these 3 nodes result in a special condition, which is if A, B and C are the distances of that node from these target nodes, then those distances should form this condition, which is A square plus B square is equal to C square. Let's take the example that is given in the question. Consider this undirected tree. Now in this tree, if 1, 2 and 3 are the target nodes, then we have to find how many nodes whose distance from 1, 2 and 3 form the condition A square plus B square is equal to C square. If we consider the node 0, then its distance from these 3 nodes is equal to 1, and clearly it cannot form the condition that is required. But if we consider node 1, 2 or 3, its distance from itself and the other 2 nodes forms the condition of A square plus B square is equal to C square. As if we take 1, its distance from itself is 0, however its distance from other 2 nodes is equal to 2. So this results in the required condition. Let's take another example. Let's consider the target nodes here are these. Now we have to find again the number of nodes whose distance from these 3 target nodes result in the Pythagorean distance condition. If we take this node for example, its distance from this node becomes 3, from this node becomes 5, and from this nodes it is 1, 2, 3 and 4. So clearly this is a valid starting node whose distance from these 3 nodes result in the required condition. Similarly, we might find some other nodes that result in the required condition. To solve this problem, we have to find the number of nodes whose distance from the given target nodes result in the required Pythagorean distance. The first thing that comes to mind is maybe we can go to each node and calculate its distance from the required target nodes. However, the time complexity in that case would become O of n squared, because for each node maybe we will do a DFS to find the distance from the target nodes, and we will do that for each and every node in the graph. So the time complexity here would become O of n squared, which is definitely not required for our case since the number of nodes can go up to 10 raised to the power 5. So it will definitely time out. So what can we do? What we can do here is we can do 3 DFSs from each of the target nodes 1, 2 and 3, and then store the required distance for each of the node in the graph. For example, if we do a DFS from this node first, then we go to this node while going to the DFS and each and every node in the graph, and for each node in the graph we store the distance from the required node. For example, if we were doing DFS from this node, then we'll store the distance here, and for this node we'll store the distance here. So we can clearly see that we are maintaining a 2D vector whose size would be equal to the number of nodes that are present in the graph, and each of the row in that graph will have 3 values representing the distance from each of the target node. For example, if we are looking at this node, its distance from this would be 1, its distance from the second node would be 1 as well, and its distance from the third target node is 1, 2, 3 and 4. So this will be the row for this node. Similarly, we can create the entire 2D row, and for each of the row we just need to find whether the required Pythagorean distance condition is being formed. In this case, we need to find out the largest number, which is 4 square, whether it is equal to 1 square plus 1 square, which is not, and then we can go to the other rows and do the similar. We'll get the number of nodes in this case very easily. So that was about the problem and its solution approach. If you have liked this video, do give a like and subscribe to this channel for more similar videos. Thanks.